which is adaptive meshing and meshing techniques in SolidWorks. Now, let's see if there is any question from your side at this point. It's time for you guys to ask questions. Are you going to record again? Chris is asking, I'm going to record. Yes, I'm going to record, but as I said, I'm not going to record the time that I'm answering the question. I'm going to just cover just a lecture, pure lecture. And during the time that I'm covering the lecture, I'm not going to answer any question, but you have time at the end to answer a question. Then I'm going to stop recording at that point. But now is time for question. And also when I review tutorial 1, that won't be recorded again. Just a lecture. Any question, guys? Come on, you should ask question. All right, seems that there is no question, which means, how are you? Thank you, I'm fine. Other than that, all right, it seems that at least for now you don't have any question. But as I said, now I'm going to review tutorial 1 in chapter 2. That's the tutorial that we went through during the last session. Now you are familiar with tutorial, you use some tools in that tutorial. And as I said, that tutorial is a very comprehensive tutorial to get familiar as much as possible with the tools that we have in SolidWorks simulation, FEA. And that's the objective of that tutorial. And I didn't cover the detailed application, some points related to that tutorial, because I wanted you guys to do the simulation, do it by yourself. At least now, when I talk about some points, at least you tried the tool, and maybe it's more clear now. Dan is asking question, for the lab assignments, are we changing the dimension of the plate via trial and error or via a tool within SolidWorks? No, that is just changing by trial and error. That's a design process. Yeah, you change and you see the result. This is exactly what's happening in FEA. Although in advanced FEA, what we have optimization tool. Just for your information, it's beyond the scope of this course. But we have what is called optimization, meaning that what you have is you have a couple of design parameters like thickness, material, I don't know, might mean in some cases forces and fixtures, and you are going to optimize for example, the weight of the part, and you should set up some criteria, and you should define the optimization goal. For example, you want to minimize the weight, or you minimize the cost, or something like that. Then there are, for limited type of application problem, there are tools that we can go and do design optimization, and then software is going to take care of that kinds of optimization. But as I said, beyond the scope of this course, for this course, you are going to do trial and error. And as I mentioned, optimization is not always for all the scenario that you have in your mind, and maybe you have to do through trial and error. Okay, next question is also for the lab assignment. Do we only upload the PDF or do we also upload the part file? My suggestion is, let me talk about assignment. Adam is in charge of assignment. I can answer some of those questions, which is technical, but when it goes to formatting, and if you have any specific question related to homework assignment, technical, feel free to ask question from me or from Adam. But when it goes to the format, or if you have some sort of problem, maybe in terms of the deadline or maybe file management, please contact Adam directly, because he's going to mark your homework assignment, and I don't want to have some sort of two source of information. Sometimes people get confused. My suggestion is talk to him directly and send him an email. He's good at email, and he's going to reply your email quickly. All right. All right, it seems that there is no question. All right, let's get started. Let me share my PowerPoint and see what I have for you guys today, at least for this part. As I said, the first part, which is going through tutorial 1. You can ask any question. Please feel free to unmute yourself and ask question, or put the question in the chat area. This is just answering your question related to tutorial 1. Let me share what I have here. There you go. Let me bring that one here. Now, this is what we have. As you see here, this is what I call FEA journey. Yeah? Starting from, as all of us as a mechanical designer like, is CAD geometry. You're well familiar with CAD geometry. Typically, we start from CAD geometry. And we said in chapter 2, we need to move from CAD geometry to FEA geometry, meaning that you need to do a little bit simplification here in some cases, and maybe some cases is not simplification. You have to, it's more than simplification, is you have defeaturing some features. And here you have to be careful. What's happening is you are going to defeature or simplify the model such that you are not going to create error. All right. Then, for example, if you are here, if you look at here, there are fillet and chamfer around the part. I can suppress those, because if objective of my FEA is to investigate the part in terms of stress and displacement, and I'm interested in finding the maximum stress or maximum displacement in this part, then I can ignore, or sorry, I can defeature those chamfer and fillet. But in some cases, today I'm going to show you this is a dangerous decision if you make, because there are some features that if you defeature them, although this fillet, but that fillet is going to contribute to your strength of material and load path significantly. And if you suppress those by mistake, then you make a huge problem in terms of FEA. Again, FEA is correct, but it's not your problem. It's going to give you a solution, which is not the solution to your problem, it's a solution to a problem that you defined. But that's not a real life problem. And we said we are going to go to what is called pre-processing a little bit more, and we are going to add load, material, type of analysis, type of element, fixturing. And this is what we did during the last week. You applied all of those, you applied fixturing, you applied material, forces, and so on. And when we reach this point, this is called mathematical model. I call that one mathematical model, meaning that at this point, although you see CAD, although you see FEA, and you're playing with the HMI, which is the interface with SolidWorks, and you're going to define all of those parameters in SolidWorks. But the reality is you are going to define a mathematical model from SolidWorks simulation perspective, which means that behind the scene, by defining any of those parameters, you are going to change the equation and what's called boundary condition. Then when you reach to this point, the problem that you defined here is the mathematical model that SolidWorks is going to solve. If you didn't do a good job here, again, you define a mathematical model, but it's not the problem that you had. You define a problem which is different from your real life problem. But from this point, SolidWorks is going to take care of the rest, and is going to do discretization, and then give you solve the problem and give you some numbers. All right, then be careful with what's happening here. This is what I called last time from CAD to the result, which is FEA journey. And that slide is from your textbook anyhow. I think that part is pre-processing is clear. We covered that one, and you're very familiar with that one, except the size of element and type of element that I'm going to talk about it a little bit now. Any question regarding the material that I covered so far? As I said, feel free to ask question now. Text area, chat area, or unmute yourself. All right. Now, let's jump into SolidWorks and see what's going on in terms of meshing and element size. I said there's a couple of points here. I'm going to, and I will cover them in tutorial. You change the element size and see what's happening there. Let me go to SolidWorks. There you go. You're in the SolidWorks simulation, SolidWorks environment. I'm going to create a new standing. And let's call that one test one. Yep. And as you see, a static is selected over there by default. Then I'm in simulation environment. That's the simulation static 3. You know that we can add, material. I think material was 304. ASI 304. Apply, close. The material is clear. We apply feature. There are different types of feature. We covered those in chapter 2. In this tutorial, we had, yeah, somebody has question. Sorry. How do you change where all the test files go again? Yeah, see what I did, for example, for this one, I put this file, cat file, in the beginning, right in the beginning. I created one folder I can show you. See, if you look at here in my desktop, I created a folder, this one. And here it says, I call that one linkfile. I put the cat file here, and then if I run the simulation, from now on, everything will be saved in this folder. Then if you put your part in a folder, all the simulation file will be saved in that folder. I hope I answered your question. All right. Now, next step is we said we are going to apply forces. I'm going to apply force. And here again, in terms of force, we have different types of forces. As you see here, we have distributed force, we have uniformly distributed force, and we are going to practice some of those forces in chapter 4. Now, for now, you know that we can apply non-uniform force, we can apply uniform force, and apply to the faces that you want, or to the edges that you want later on when you go to shell. Then you can apply force. And if you look at here in simulation command manager, here you see in external load advisor, see you have different types of force. We covered most of them all the way to gravity as far as I remember, and the rest you have to cover them in assembly. You should have assembly to look at the rest. But here we said we can add gravity, pressure, torque, force, and so on. And when it goes to the force, we said if I select any faces, I can apply force. However, that's not the only option that you have. If you go to selected direction and look at your textbook on chapter, I think 2 pages, I'm going to show. Please write down those pages: 2, 24, 25, 26, 24, 25, 26. Over there, I gave you a couple of examples. If you go to selection direction, what's going to happen? What's going on here? It means that it doesn't have to be always to the one face. Oh man, come on. Somebody making noise. All right. Now, what's happening here is, if you go to those pages that I mentioned, you can apply any direction. You can select this edge, for example, and then that edge is selected. And you can say, apply force to this edge, and you can go and define the the other parameter. In this case, again, we are going to talk about those, but as a reference, please read 24, 25, 26. Now, I'm going to apply a force. And here, let's go with the maximum that I had was 45,000, because I want, although it's too much, it's going to pass the user strength, but I want to show something that it's good to have the maximum and should change the direction. All right. Now, here's the point. See, it seems that everything is ready for analysis. If you look at that roadmap from CAD geometry all the way to FEA, it seems that we are ready to say run. However, the question here is, what we said you are going to make a decision about type of elements, but we didn't make any decision about type of elements. And also we said we are going to make a decision about size of element. So far we didn't make any decision about these two, which is no decision about the type and no decision about the size. Let's see what's going on if I want to mesh this one. What I'm going to do, I'm going to say create mesh. All right. And here, what's happening here is that slide, as I said before, this is something roughly like a slider. Yeah, you can go with number as well. The default value here is always there is a default. Some students asking question, what is that default? That default is good. SolidWorks is going to, I don't know, some sort of number, going to divide the total area of this part by the volume and reach to a number. Who cares about this number? But that's the default. And then you can change that one. You can move that one to the coarse. This is 15 millimeter size, and go to the fine, which is in this case 3. But it's not your limitation. You can go here and say I want to apply, I don't know, say fine is 2, more than that. Or I can go to coarse and say instead of this coarse, which is the limit, is 15, I can say I want to have 20. That is just a number. You have control over that number. You can play with that one roughly if you want to. You don't care about the numbers. All right, let's reset. The reset, when you go to here, the default is the number that I mentioned. You can go to the course code. But what about different types of elements? This is the size. What about the type? Type of elements here is, let me see if I can show it here. I have to go back to, let me talk about the type of elements when we go to chapter 3. But for now, we have 2 types of element here. This is solid, then you have solid element, 3 degree of freedom at each node. But you have 2 types of solid element. We have what is called draft, and we have what is called high quality. Or we have math language. We have first order, which is rough, and second order, which is high quality. The draft is first, and then the high quality is the second order. The default for now, I'm going to talk a lot about this one, but in chapter 2, chapter 3 is completely about meshing and sizing and type of elements and so on. There are so many things related to this topic. But for now, keep in your mind that if you don't touch anything, the default element for solid part, if you are using solid, which is here, as you see, we have solid, that represents the solid element. Then the default for solid is second order element, which is called TET elements. I'll talk about TET elements, but it's second order. That's a default. If you don't touch anything and you're going to use it. What is the difference between first and second? Is there any other option? Let's talk about it in chapter 3. But for now, just keep in your mind that what you have here is just second order. It's the default if you're on simulation from now. All right. Now, I'm going to create a mesh. But what I'm going to do here is, I'm going to create a mesh. What I'm going to create here, I'm going to start from course. create mesh, and I'm going to course and run it. Still, I haven't run the simulation. I just discretize them all. As you see, it's really courses, huge size of element. I can get more than that, but I think that course was 15 millimeters, something like that. This is what you have. All right. And I'm going to run this simulation. Should be quick because it's course, yeah. And now I'm going to create a new study. Again, I'm going to go to the study, right? Let's call that one test 2. Test 2. This time, same material. We are not going to change the material. I'm not going to change the force. I'm not going to change the fixture. I'm going to apply fixture. And I'm going to apply force. That was, I think, 45,000. All right. And this time, when I go to mesh, I'm going to go to default. I think the last one was course, yeah? I'm going to go to default and run it. And run the simulation. Now I have, if you see here, I have 2 analyses, test 1 and test 2. Okay. Now I'm going to create a third one. Let's call that one test 3. And this time, same material. Same force. And same fixture. Okay, now I'm going to run. This is test 3. Takes a little bit more time. We know that. If you look at here, we have the sizes completely different from what we had. Now, what I'm going to do, that was 3 something, 3 point. I'm going to this time, I'm going to enter the number. I'm going to create a new study, which is, let's call that one verifying, yeah? Let's go to call that one test 4. And static, yes. Material same. And fixture same. Force. $45,000 here. Change the direction. There you go. Let me run. It takes more time, yeah? And we expect that. Okay, temporary file, please check. Failed to create temporary file, please change. Something happened in terms of saving this one. Let's see what happened. That's a file management. Let's go to desktop. Link 4. Oh, we have everything over there. That everything is okay. Yeah. Now, then we have test 1, which was course, test 2, which was default, but I realized that I didn't change the direction of this force. Okay, let's change that one to be consistent. Yeah, there you go. And when you change that one, you see that yellow, which means that you have to rerun it. Hopefully it's not gonna create lots of file and it's not gonna give me error. Good. And we're going to look at the test number 3, which was define and verify was that. Do we have the stress result? Yeah. Now, there is one option here. You may want to use it. If you go here, where was that? Compare result. This one. If you go to compare result, you can say, I have, for example, in this case, I have 4 simulation. And what I'm going to do here, I'm going to look at the stress and between all simulation. I just want to look at the stress result between all simulation. Again, here there is a compare result, and that one is in your textbook as well. I'm not sure it's in chapter 2, but in chapter 3 we have it. Now, here you can compare the result, and I'm going to look at the one which is the stress result. And what's going to happen here? See, let me minimize this one. I can see it. All right. This is for a study. Let me just go here. That one is test 2. That one was the course, which is test 1. And this one was test 3, which was fine and was very fine. I think these two, we don't pay attention to this one because these two, there was some error message file manager from my side. Now, let's look at here what's happening. If you look at the magnitudes of the stress, see, it's changing. From this one, it's changing to 113. And from here, it should change that one as well. Let me see. If I go, maybe we made a mistake somehow in terms of the values. Let me exit from compare. And let me go to test 1. And let me see what was the mesh. Yes. I'm going to go from course. All right. And I'm going to run it one more time. That was the course, and the force is for 45K. Now, test number 2. Let me see what was the mesh. Create mesh. Okay. Yeah, that's a default. That's a good one. We need to have that one as well. And run it. Okay. And test 3. Let me see. Create mesh. Okay. Yeah, see, we made a mistake here. We shouldn't move that one to fine. Forgot to do that. All right. All right. And now I'm going to run it. Now we are running the simulation with fine mesh. All right, now it's changing, see? And then let's go to the last one and see what happened here. Last one, I'm going to say mesh. The force is correct, everything is okay. Let's go here, create mesh. That's supposed to be 2 millimeter. No, it's not 2 millimeter. Let's mesh it. It should take more time. Hopefully I can run it because I'm sharing the screen and it's 2 millimeter is very small. Yeah, as you see, it takes lots of time because I'm sharing the screen at the same time I'm running so many things behind the scene. But at least you see what is the, yeah, there you go. Now we have meshing. I didn't run the simulation yet. Yeah, this is 2mm mesh. And this time I'm going to run it. It takes lots of time, but let's give it a try. I hope I can run it because I saved lots of simulation at the same time, and it may take a couple of minutes. In the meantime, if you have any question, let me know. It takes time to run the simulation. Any question about what I'm doing here or what's going on? No, there's no question. All right. Now, as you see here in SolidWorks, it says that it's running, but it takes lots of time because we have various small size. And this is, don't forget, it's the simple part. And I said 2mm. And these kinds of time, it's normal. Let me just stop sharing. And it takes time. Let's run it behind the scene, be a little bit faster. That is 2mm. And I ran the simulation in a couple of projects that I had. It took me 5-6 hours. And I have workstation. I don't have those kinds of Costco type laptop. 5-6 hours with workstation. It means that it's normal to spend lots of time in terms of simulation. Then in this study, you ran a couple of those in your tutorial. But let's see what happened in that tutorial. Why we had that kinds of repeating the process, the different size of the mesh. What's going on in terms of the result? Now it seems that simulation is done. Let me just back to simulation. There you go. Here, this time I'm going to again compare the result. I have 4 simulation. I'm going to compare those results. Come on. Will not crash. Okay. I'm going to say I want to have 4 all study and say yes. Okay, as you see in SolidWorks now, what we have 4 study based on 4 types of element size. I didn't change anything except the size of element. It's running, hang on. Good, go, you can make it go. All right, now what's happening here is, come on. What's happening here is, as you see, the magnitude of stress is changing from one simulation to another one. The reason that you have this problem is, this issue is a problem. The issue is the magnitude of stress is a function of the element size. And this is what we call discretization error. Remember, some of you asked, what is the discretization error? That's the discretization error, meaning that you may have the result, but that result is not good enough based on your mesh size. And you may say, okay, what would be the best size? The best size is something that we are going to practice in chapter 3. And in lecture time, I'm going to talk about it. But just for your information, this is what's going to happen in terms of stress result. Also, if I compare the result from displacement perspective and just select the displacement, okay, this 3 is enough. Oh, darn. See, lots of simulation is here not running properly. See, if you look at the displacement, for example, between test 1 and test 3, as you see, to 3 decimal places, it seems that there is no change. I can go there. I have to stop sharing. I can go and change that one to 4 decimal places. Even I think to 5 decimal places, almost they are same. What does it mean? It means that simulation, and when it goes to a result in terms of displacement, is not that much sensitive to element size. Stress was sensitive, but the displacement is not that much sensitive. It is sensitive, but it's not that much sensitive. And I'll talk about that one why. But in chapter 2, we said that run the simulation and compare the result. Okay. The question is, on what mesh size the exam question will be? Will be fine because fine mesh will crash the system. No, here's what's happening. For the exam, I'm going to the question. Have question privately, but I think it's something that you can talk in general. Higher mesh size for the exam. I said, you know what? I'm going to determine that one to make sure that your computer is not going to crash. Because if your computer is going to crash, then you have a problem. Then don't worry about that one. I'm going to find the size that with typical computer can run. This is what I want to say about element size and element type. Now let's back to that PowerPoint one more time. Any questions so far? All right, it seems that there is no question. Let me just go and share the PowerPoint. Again, PowerPoint is from last week, nothing new, just answering a couple of questions that I have from a student. Now, next one is processing, which is the mesh size. We covered that one, and you can't do anything about process. Computer is going to do processing based on your setup. But what we have is post-processing. Now, simulation is done, and then you have some tools. You can look at the stress plot, we can look at the displacement plot, section plot, probing, animation, factor of safety, design insight plot, fatigue check plot, and report. I'm going to go through those, although you practice, but a couple of questions that a student had and asked me, and I think for most of you would be very informative if you know what we have and what's going on in terms of the content of those tools, or what is the objective of those tools. Let me just go to SolidWorks one more time. That one is very straightforward. What I'm going to do here is I'm going to, not this one, that one should be here, that one should go there. All right, now let's go to SolidWorks. And I'm going to just work with one of those tests, say test number 2. All right, and let me share SolidWorks this time. There, I'm just focusing on one of those simulations. Doesn't matter which one. I selected number 2 because I want to talk about some of post-processing. Post-processing means that as you practice, we have a stress result, for example, we have displacement result, and we have a strain result. Do we have to limit ourselves to those 3? No, you can have more than that. All you need to do is, as you did during the tutorial, you can go here, say, you know what, I want to have more a stress plot. And if you go here, you have define a stress plot. And here you have, for example, normal stress. Sorry, this is a strain plot. You want to have a stress plot. There you go. Define a stress plot, not a strain plot. Now, here what we have normal stress. We can have shear stress. See, we can have principal stress. Remember principal stress, the maximal stress that you can find in an element in your strength of material course. You can plot those, and so on. There are lots of results here. Also, you can come here, and here it says you can have a tensor plot. If I say show as tensor plot, some of you ask question, what is a tensor plot? And you plotted this one in this tutorial. Here's what's happening. Tensor plot is going to represent the distribution of a stress plot. principal stress. The distribution of principal stress in part is called tensor plot. It's good to know because principal stress is important, and the reason is that represents the maximum stress. And you may want to look at the distribution, the direction of that stress plot or principal stress in a part. And that's the application of tensor plot. That's gives you that information. Where is the direction? In some cases, you may want to look at that principal stress. Other than that, see, now we have it here. Now it's called stress number 2. You can go here one more time, the stress plot. And then you can plot the stress plot, principal stress itself. All right. Then all in the textbook, I explained all of them. Please read them carefully, and you can see what kinds of stress plot you can have. Other than that, we have, this is obvious, you want to select some entities and show them. We have node value and we have element value. Let's talk about this in chapter 3, but what you see here is node value. At each node you see the result, but you can have the average for one element. This is for us in this course not a big deal because we are going to look at the node value as a default, but average means that for example, one element has say 10 nodes and each node has its own stress. Very close to each other, you may want to have the distribution based on the average, not based on for some application. That is there. One more thing here is very interesting is deformed shape. See, if I go here and go to a stress plot, see, if I animate this one, remember that this, if you look at the displacement is maximum is how much? 0.03 millimeter. Very, very small, yeah? But if you animate this one, it's huge. It's more than that. From here to here is 100, but displacement seems at 10 millimeters, something like that. Because it's going to exaggerate the deformation. Same goes if I want to look at the result. Here it says deformed shape, and if I unclick on that one, deformed shape. If I want to look at the deformed shape, it's huge. It's not 0.03 millimeter. What's happening here is this. See, it says the exaggeration that you see at this point is 6 to 9, about 630 times bigger, just because SolidWorks want to show you. Deformation scale is here as well. It's 630 or 620 times more than what you see. If I say go 2 scales, all right, and say okay, now see what's happening. If I go to deformed shape, do you see any changes here? See? I'm going to say deformed shape, no deformed shape. You can't see anything because that's showing you 0.03. That's another thing which is interesting you have there. What else? All of those tools that I'm processing, that talking, everything is in your textbook. Please read your textbook, lots of useful information in more details. But I just want to touch on the key issues. Section plus, let's see what's the section plus. I can go here, and in some cases, you may want to investigate what's going on at the thickness, because that part has a thickness, yeah. And you want to see what's going on in the layer, inside this part. And you can go here and where was that? I can see it from here. Create section plot. Come on, go to stress and create section plot. Now what's happening here, I can change the direction. For example, I can say instead of front view, let's look at it from, say, right view. All right. Now, this is the section view. You can see what's going on here in terms of section. In some cases, this is not an important issue for this part, but in some cases, you want to investigate the distribution of stress or displacement in a particular plane in the part or in particular location in the part. You can go. And there are different options here. You can go cylindrical, you can go spherical, and start playing with section planing that you have. See, you can see this out. I can move this cylindrical shape and can see that cross section here. See? Those are things that we have in section clipping. Probing is another tool that we have. We can go here and probe the result, can move on, and you can measure, probe wherever you want. That is like a sensor, measuring the value at selected point. Yeah. That probing is very interesting, and you can probe and then you can plot. If you probe it properly, say along at one edge, and you want to see what is the distribution, you can do the probing, and then you can go here and say plot the result, and it's going to plot based on your selection. As you realize, I selected a couple of points here, which is not a big difference in terms of stress. Suddenly, I move to this area, which is lower stress. That's why it's coming down. But is it something that you want to pay attention and this tutorial? No, just I want to show you that you have this tool in case if you need it in your any project. That is something part of probing. Animation, yes, we talked about animation. I showed you animation. I said you can create the animation, but you may say, okay, what is the application of animation? Let me just go to here and change that one to automatic deformation instead of what we had. I'm going to here and say go to automatic. Then I have that exaggeration as well. I can come here and say, oops, animate that. No. Okay, we have animation here, and you may say, okay, it's beautiful, it's good, it's cool, but what is the application? Do you think SolidWorks is going to spend lots of money to create this tool to make something fancy over there? Anybody knows what would be the application of animation? And you see, as you see, there is no number here, it's just animation. Get back to, does anybody have any idea what would be, visualize the deformation, visualize. Yeah, this is definitely animation is visualization, but Jay, you said visualize the deformation. You're right, but why we want to visualize the deformation? What is the application? You want to see it? You want a presentation? What? Any idea? My question is, does anybody know what is the application from designer perspective, not from just playing with software? Any idea? Any idea? Come on. We have 60 students. See where max strain is. And okay, let's see a couple of dances. Shows someone who doesn't know how to interpret the result. I have no idea what they're talking about, man. To see the critical points, you can see the critical points, but you are close, but you can't see anything. There is no numerical value. Mandip says, can't know about the behavior of what area needs to be addressed as load is applied, the load path. See what the objective would do if under greater loads, to figure out what are may need to be a strain. Good, thank you. Now, a couple of you, some of you mentioned, Simon mentioned, for example, you can see what area is weak, or maximum stress is there, and you have to strengthen that area. Yes, that is. I think. Let me just back to SolidWorks. I think more or less you mentioned, some of you a little bit more precise, some of you have the feeling of answer, but you didn't precisely mention that. Here's what's happening. See, this is a simple part. When I animate this part, it's gonna show me the terminology that I use in the textbook, and I'm using it here, is what is called overall behavior. Right? You can see overall behavior of your part or later on assembly. Now, what is the application of that overall behavior? Overall behavior, first of all, this is a very simple loading scenario and fixturing scenario. You have only one load, one direction, one fixture, one direction. That's it, and that's all. But what about you have a frame or chassis, and you're applying load, and you want to see if what's happening, what is the mode of deformation, how it's going to deform. And that is critical because you want to apply load. Then you want to see that one. This is one. And the second is, somebody has a question, something. All right, let's see. I'm going to look at your question. Just give me a second. Next is, to some extent, not always, but to some extent, it's a good tool to look at your fixturing and forcing. Because as I said, this is a simple one, but what about if you have a steel structure and you want to do a FEA? By animating, if you make a mistake in terms of fixtures and load, you can see it. And you can somehow, don't quote on me, it's a trick. You can look at this simulation animation and see, okay, you know what, I forgot to apply fixture somewhere, because you can't catch those points. At least you have one more tool to help you. It doesn't mean that if you use this tool, then everything is okay. No, but at least you have this tool to help you if you forgot to apply fixture, if you apply force, or overall behavior helps to look at the distribution of the formation in order, as a couple of you mentioned, find the weak point or strength those area. And also is going to help you to check your model, make sure that your modeling is, as I said, to some extent is a tool that you are going to use to get some sort of feedback. Somebody had a question. What was the question? All right. Second, is this lecture being recorded? As I said, this is not a lecture. This is, as you see, we have question. I think I mentioned 100 times. This is not the lecture. This is just question between you and I'm not going to record those kinds of questions. When a student have question, I'm going to answer, I'm going to explain. Those are things that a student should be here. It's not, I just want to make sure that everybody knows what's happening. But the lecture, which is next hour, we are going to deal with lecture, will be recorded. Now, one more tool that we have, two more tools that we have. I'm going to quickly talk about those, and then we have 10 minutes break. Now, next one is design insight plot. If you look at your textbook, and this is what you did, there is one option here. It says define design insight plot. Let's give it a try and see what's happening. See, here is a very interesting, very interesting tool that we have. I can move that one, and as you see, something is happening here, and there is some percentage here. See, I think one of you mentioned somehow for animation, but maybe this tool is better. This tool represents the material and the area of material that it's going to distribute to take the load. See, this area is going to distribute significantly to take the load. And when it goes to here, that area is not going to distribute to the load that much. And we know that. If you apply this load, that area is the weakest area. But this is obvious here. This is obvious here because part is simple and we know that this area is minimum area. But what about if you're dealing with the complicated geometry and everywhere thickness is same? Thickness is same. And you can, by naked eye, just look at the simulation and say, okay, you know, that area needs more power, more material. Then you know that if you want to make this part more stronger, this is the area that you should add more material. But again, for this part, it's simple. But the principle goes very complicated. For example, if there is a truss, if there is a steel structure, it's a frame, a chassis, injection molding part, you can't, by looking at the simulation, say, okay, I know this area is weak. It's not that easy. But you need to strengthen the part. Then you're going to use this tool. This is one. The second one is fatigue analysis. In that tutorial, I said try to find to run this tool. We are not going to use this tool, but it's an interesting tool to know. This tool says what? Define fatigue check plot. This is fatigue check plot. It's not fatigue simulation. When you have cyclic loading, which is fatigue, you have to have another set of simulation, which is fatigue simulation. However, you want to make sure that is the fatigue is a concern. Later on, when Olivier is going to talk about fatigue and all this in machine design course, you quickly realize that fatigue is a huge issue because yield strength say 400 MPa, but in fatigue maybe 40 MPa. Then you are design. If you don't take care of fatigue and don't realize that one, and you design for yield strength, then what's going to happen is you're going to you have factor of safety is say 5, but the reality is factor of safety is 0.5 because you didn't consider fatigue. But all the equation factor of safety is there, but it's not working because you have fatigue. Now, how should we know that fatigue is a concern? That check plot is going to help us. If I invoke that tool, there are some setup here. You can read the textbook to see what are those. I'm going to accept as is. All right. And I'm going to run this simulation. It seems that that one is not. I have to change some parameter. Let me see. If I go to this one, edit definition. Let's go to that one. Let's see if it goes with alternative loading. No. What about if I change the force significantly? Yeah, let's go and change that one. With this force, this configuration, fatigue is not a concept. That was a good example to see fatigue. But what about I go here? What about if I apply 100K and run the simulation? Hopefully that one is going to show me something. Here you go. See, it says that if you apply 100K to this part, there is an issue, sensitivity or fatigue issue here. Be careful. That's all you know. It said be careful. Yeah. What should you do? You have to do fatigue analysis. Check that from fatigue perspective. It's a concern. It doesn't mean that you have to, but it says that now that red area is a concern. And finally, one more thing that I mentioned in that tutorial is creating report. Creating report is a tricky issue in FEA. It's not a CAD. You can create a shop drawing because it's fairly to listen to Microsoft Word. Please make sure that you have proper. Anyhow, it seems that I can't create the report here. For some reason, my Word is not. Because I think I have Office 365. It says that it needs to have Microsoft Word 2003 or later. All right. But anyhow, if you look at here, just give it a try in your home computer. Click on that one. It's going to create a Word document. It's exactly a Word document. And in general case, maybe in some cases, 20 pages. You don't have to keep the 20 pages. If you look at my that section that I explained, this tool you can customize. Say, okay, I don't need this, but it's going to create a wonderful report, professional report from your FEA, and all of those numbers set up. There are lots of snapshots that is going to take care of from the mesh and so on, and put it in that report. And then you can. That's a Word document. By the end of the day, you can customize that. You can add text. You can delete, and it's a Word. But everything will be generated automatically. Okay, that is the last one that I want to mention. The one more thing that I think you practice is if you go any of those plots, I go to edit definition, you had this one as well. See, chart option, you can show the maximum, show the minimum. You can go here and floating number is 3. You can go and have it scientific, general. You can put this legend position anywhere. You can put it on the right. You can put it up, down, those kinds of things. But one thing, and that just some students asking where can I find maximum minimum? Here's the maximum minimum. But the last one I want to talk is this one. It's a fringe option, and we have model mesh. Okay, fringe option is what you see is continuous. I'm not going to change the simulation. The way that you can see the graphics area, this is continuous. You can go say, I want to have, say, discrete. Now see, it's going to create an area with very close distribution of stress. This area very close in terms of stress, this area very close, that area is very close. The area is going to group them based on area. You can group them based on line. That's another way to look at the distribution of the stress. And also you can go even with point, which is in this case, it's very doubted you can, I think I can see it from here. I'm not sure you can see it when I can see the dot point over there. And also let's go to say continuous, the default one. And also you can impose the mesh. Okay, if you want to impose the mesh, for example, you want to see, okay, I have maximum here, what's happening here in terms of mesh, or you can have the result and you can the number of elements. Then you can impose the mesh as well. All right, that was my review and answering some of your questions. And if you have any further question, please let me know. Otherwise, we're going to have 10 minutes break. That what I did, I just wrap up chapter 4, not a new material. That was answering some questions that the student had, and just make sure that that chapter 2 is clear. What was the objective and what do you have content-wise, and what are the application of those tools? All right, it seems that there is no question. Now is 3:35. Let's have a break until how to optimize the whole size in assignment question. You have to play with that, trial and error. Go trial and error. And the question is, I think a couple of students asked question, is there any automatic or I don't know, optimization? I said there is, but it's not beyond the scope of this course, and it's not general for all the project. What you need to do is for that particular homework assignment, which is we have, that the reason I have that assignment in this course, I want you guys to see right in the beginning. In the beginning, you see, okay, what is the application of this tool? I'm learning this course for what? In the beginning of this course, you see there is a problem. You're going to run the simulation and you can change the parameter and you end up with different result, and you can validate your result. Then you are going to go through trial and error. All right, let's have 10 minutes break and back to lecture. I'm going to record the lecture next hour, which is at 3:45. Then see you at 3:45.